and share my screen. And there we go. So again, like normal, I have Python tutor pulled up, and we're going to go over all the problems in class. I'll write the answers on the board up here, and you'll grade your own quiz. On this first problem comes from almost exactly like one of your quiz problems or practice problems, with the exception of how the indexing is working down here is a little bit different. I'm just going to jump to the very end here, and boom, we get true right here. The reason that this is true is that we have S at position -2. So on the string counting from the right going to the left, because it's a negative index, 0, L right here. That's the index that we're looking at inside of the string. And then XS is the list. We're looking at position 3 coming from the left going right, 0, 1, 2, 3, this L right here. And they're both string L's, and so we get true. If these were slices in any way, it would be false, because a slice for a list always gives you a list, and a slice for a string always gives you a string. And so a string can never be equal to a list. So if this were slices in any way, it would be false, but because it is indexing, we get a true value right here. Number 1, true. Any questions on problem number 1? Okay, you all don't like asking questions about the quiz problems. That's okay, but you should definitely feel free to ask questions. There's problem number 2, and again, you all should be making sure that I got my copying and pasting and everything right into Python tutor over here. And so we create this string Guido von Rossum like this. There it is down here. And we do this XS equals S dot split. When you have split without anything in the parentheses, what it does is it splits on the spaces, giving you the words in the string. So I press next. And XS right here contains Guido, von, and Rossum as 3 separate words. And now when I do XS at position 0, it gives me this one right here, the very first word in that string, and prints out Guido for number 2. If you had quotation marks around Guido, then that in your output over here, that's totally okay. You can still give yourself full credit. Just the important thing is that the thing that you're printing out is Guido somehow. That answer your question?
Yeah, that was the exact question.
Any other questions about problem number 2 here? Okay, a quick digression on Guido. Again, Guido is the inventor of Python. Here's a nice picture of him here. I always like to look at pictures of the famous people that I encounter in my studies. And so this is what Guido looks like. We know that, so I've mentioned before that programmers, hackers always call each other by our first names, that we have other ways of understanding hierarchy rather than titles. And so we know that the editors of Wikipedia here are not hackers because they're calling him Van Rossum instead of Guido. And so Python's an example of an open source project. Most open source projects are started by just an individual person. And if they become popular, that individual person becomes known as the benevolent dictator for life of that particular project. Depending on the person's style, they may be more or less dictatorial or more or less benevolent. And this for life thing right here, Guido actually stepped down from being the BDFL in 2018. So people still call him the BDFL, but he's actually not involved in, he still uses Python, but he doesn't make any active decisions about what features should go in or not in the language anymore. There's something called the Python Steering Council, which is a sort of democratic body that decides what features get added to Python or not. Question?
Was this his job? Did he make money off of this, or is this just kind of a passion project?
Yeah, the question is how how did Python actually start? Was he paid for it? When he first started Python, he was a student at the University of Amsterdam. I believe it was a master's program that he was in. This was in the 1980s. And he was frustrated with the features of the other programming languages. And so he decided to start Python. It didn't really become popular until like the early 2000s, and so he was doing other things to make money during most of Python's life. But then eventually, once it became popular, he was very, very highly sought after. He worked at Dropbox for a number of years, and Dropbox was famous for hiring him because his only job at Dropbox was specifically to work on Python and not touch any like actual Dropbox code. And they never disclosed like his actual salary, but rumors have it was in the millions of dollars per year. And so it was basically like on Dropbox's part, an advertising campaign that rather than throwing millions of dollars on TV ads, which is not where like hackers would learn about Dropbox from. Instead, they spent millions of dollars hiring famous programmers like this so that other people, like the people they're trying to recruit to work at Dropbox, would say, "Oh, I want to work with Guido," and so they'll go work at Dropbox because of that. He since left Dropbox. I forget exactly the timeline, but I think it was basically when he stepped down from being the BDFL, and he currently works at Microsoft, doing sort of Python adjacent stuff, but again, he's not like the overall person in charge of Python anymore. So all that is a prelude to a slight professional embarrassment, actually an extreme professional embarrassment on my part. In these problems, I said V-O-N, von Rossum. His name is actually Van Rossum, V-A-N. That Dutch people, for whatever reason, they use V-A-N as, so here, Google Van versus Von tells us the difference. Dutch people, and for some reason Vietnamese, use Van as their prefix. Every other country in the world uses Von as their prefix. So shame on me. But problem number 3, also with our Von misspelling right here. So there is our string S. And here is the key part right here on number 2 when I press next. So here we're looking for the capital G. There is no capital G in here. But also, anytime you have a string and you have a string function, that string function does not modify the string in any way. It returns a new result. And if you want to use that new result somehow, you have to assign it equal to a variable. Like in the last problem with the split, I assigned it equal to this XS variable. Here, I'm not assigning it to any variable at all. So it's like that line never even happened. You can see that when I press next here, actually executing that line, nothing at all happens. So when I do T equals S at position 0, all I get is the letter G, the lowercase letter G for number 3. And again, I don't care if you have quotation marks around it or not, just as long as if you feel like you understood that it's just the letter G, then I will trust you to grade yourself honestly. Any questions about this problem? Yes, Henry.
If it had been like T equals S, or like let's just say U equals S dot split G, and T U index at 0, it would be the entirety of Guido von Rossum, right? Oh yeah.
So here now it changed S to be the list that contains the string Guido von Rossum. There is no capital G to split on, so it just puts it all in one entire thing. And this version of the problem would give me the entire string like this. Yeah.
Yeah. There was one where it's S dot find, and it was fine for capital G, and there wasn't a capital G, so I think like Python tutor showed like I being -1.
That's true for find, yes.
Fine. So is that something like if it isn't in the string, it should be I should be -1.
Yeah, so the question is about a different function other than the split function. The question is, what if we had something like I equals S dot find, and then we use a letter that doesn't exist like this? Then no matter what that letter is that doesn't exist, that I value is going to be -1. Yeah. Good questions. Any other questions about this problem or anything remotely tangentially related to this problem? Okay, problem number 4. So here we have two characters, two strings that are being compared. The way we do this comparison, the way we do this is we have to look up the number that represents these particular characters. Again, the way we store characters, the way Python under the hood stores all the strings is everything is just a number inside of a computer. So these characters have numbers associated with them. And if we come back over to our Python cheat sheet right here, we need to find the greater than and less than signs. Here's the greater than and less than signs. And it corresponds to the number 60 and 62. So the less than sign has the smaller number. So the less than sign is smaller than the greater than sign. If we come back over here, so this is the less than sign over here. This thing is asking whether the less than sign is smaller than the greater than sign, and we get true for problem number 4. Again, the main way that this comes up in practice is that when we're sorting things, when we're sorting strings, we sort them ASCII-betically or Unicode-betically if it's a non-English string. And so you need to understand that even though like letters have some sort of semantic ordering in different languages, Python and every programming language actually is totally ignorant of that, and it only sorts by the numbers that it knows about under the hood that it's using to represent these characters. Any questions on problem number 4? Yes, Freya.
On the practice quiz, there was problem 15 where it was doing a comparison as well, but it was like a backslash with a quote greater than backslash with an N.
So again, anytime we have a backslash inside of our string, it is going to, this is just a single character right here. This single character is the new line character. This right here is a single character. This single character is the double quotation mark character. And in order to do this comparison, you have to figure out what is the number associated with each of these values. The number, I'll do it in Python here, doing a little bit of review from what we saw before. There's this ORD function, ORD, which gives us the number that corresponds to any particular letter. So the number that corresponds to the capital A is 65. If you look that up in your ASCII chart, it should match. The number that corresponds to the backslash quotation mark is 34, backslash in is 10. And so backslash in is less than backslash quotation mark. The backslash in is, so on this ASCII chart, all of these things over here are represented in what's like the official ASCII symbol for the character. And it turns out that this, so 10 corresponds to this LF right here. That's the official ASCII character for the new line. I didn't ask that on the quiz because I didn't want you to have to like memorize what all these different things are. If on future problems, if something like this comes up, then it's only going to be something that's like obvious what the ASCII character should be. So in particular, nothing from this leftmost column over here. These are sometimes called the control characters in ASCII because they just do weird things.
Okay, so the hypothetically the LF indicates like the space, the backslash.
And the particular type of space which is hitting enter on your keyboard, not the particular type of space which is pressing the space bar on your keyboard. Good question. Any other questions on problem number 4? Okay, problem number 5. So again, this problem is looking up, converting the hexadecimal values into particular letters. And anytime you see the backslash X inside of a string in Python, you know that the next exactly two characters are ASCII, the hexadecimal values that correspond to an ASCII letter. So \x44, come back over to our chart over here. I look in the hexadecimal column. X is short for hexadecimal. 44 right here gets me the letter D right here. Notice that I'm not looking up 44 in decimal, getting the comma. I'm looking up 44 in hex, getting me the D. And if you do that for all of them, then you get that this string comes out to be dead beef. So number 5 is dead beef. Any questions on problem number 5? Okay, quizzes out of 5 points, total it up, and somehow get your quizzes up to me, please.
Have you met Guido ever?
I have not. Any other quizzes that I should have? Okay, let's refocus here. Last time, so we're gonna go over just super quick review of what we talked about last time. The big takeaway is this meme right here that whenever you're working in a programming language, don't use ASCII because that only allows you to use English letters in your strings. And we want to be more generic than just English. We want to work for people who live in countries other than the United States. And so Unicode is going to be our system for doing that. We're going to be going over today, finishing up this notes underscore unicode.py file and this notes_py file as well. So you'll want to have both of those 2 files downloaded. While you're getting those pulled up inside of VS Code, I'll just say a little bit more about dead beef right here. So there's a 2-minute story time while you get things set up for yourself. In the hacker world, especially starting in the 80s, it was really common for people to, anytime you have like an arbitrary number that you need to use for whatever reason in your code, for people to write those numbers out in hexadecimal and to try to make them like be English words somehow. So this number dead beef, if we come back over to Python down here and I type out 0x dead beef like this, recall that a 0x at the front of something means that everything after it is going to be interpreted as a hexadecimal number. And I hit enter and it happens to be this number right here, 3.7 billion. And so if people just need an arbitrary number in their code, this is a common one to use. The particular origin of dead beef is there's a hacker group from the 80s called the Cult of the Dead Cow. Cult of the Dead Cow. And they famous for making a lot of tools that ended up being used to break into banks and the FBI and whatnot. And so this dead beef is an allusion to the dead cow and the Cult of the Dead Cow. If you recall as well that in this class, besides these sort of technical assignments that we have that we're sort of doing in class, there's also this caveat task that you have to complete in order to get an A in the class, or an A of some form like A-, A+. And in order to do that, you have some reading that you have to do or some videos to watch. And both of those options somehow discuss the Cult of the Dead Cow inside of them. So you'll see that come up and see some of their influence on hacker culture when you do that caveat task. Okay, so today, notes_unicode.py. So I'm leaving the interactive Python session that I had right here. Let's get interactive Python loaded on this particular file. We know I can do that with this triangle button up here. that runs the file when then does not start interactive Python. In order to start interactive Python, I now press the up arrow, move my cursor all the way to the left until it gets between Python 3 and the name of the file over here, and add the -i. The -i stands for interactive, and I press enter, and now I know I'm in the interactive Python mode because I have the 3 greater than signs right here, and I know I now have access to all the contents of this file, because if I were to type something like Chinese, I have access to that Chinese text right there. Question, Jackson?
Could you also just type Python 3 and then anything else?
Question is, what happens if I type Python 3 and nothing else? That also takes me into interactive Python. Depending on how your computer is set up, this may or may not take you into interactive Python. But what you can always do is whatever the triangle button, whatever the command from the triangle button is, you can copy and paste the very first part, which is what's called the full path to your particular location in where Python 3 is installed on your computer, and hit enter, and that will take you into interactive Python. But this version of interactive Python does not have access to the contents of this file. It didn't actually load this file because you didn't tell it what file to load. And so when I'm working, I use interactive Python like this very frequently, just to like do some, I don't know if I ever need to do math or something, I'll open up Python and write my quick math equation. If you actually want to have access to the file, you need to have this -i and this file path over here to the right. And now when you're in interactive Python mode this way, you have access to all those variables. Great questions. Any other questions about the setup of where we're working right now? Okay, the main takeaway from last class, well, I guess a little bit of more meta stuff first. My hope is that the last class was relatively like, I don't know, straightforward, easy-ish compared to some of the previous things, and that the quiz this week, straightforward, easy-ish, because of a lot of students, a lot of other classes have midterms this week, and so I wanted this class to be relatively light. And I think the difficulty of next week will also be on the relatively light side. Hopefully, if you feel like you're behind on any of the material, that'll give you a chance to catch up on things. But then we'll start seeing some more like, I guess the more like thoughtful, have to think through weird things, real analytic stuff, in a couple of weeks, like 2 or 3 weeks. Jackson first.
Are we gonna get one of those quiz practice papers for this quiz?
So the question is about next quiz, exactly what's going to happen. We'll talk about it next week, but it's basically going to be like a review of all the previous stuff. So same question. Okay, good questions. So yeah, main takeaway from last class is that languages are weird, human languages are weird, and Python, as much as is possible, is able to handle those things automatically for us. Maybe so highlight some things we didn't talk about last time, but interacts with our quiz a little bit. So if we had like any string in English and we use this .split function, it somehow splits things up into words, because in English and in most languages, we separate words with spaces. Chinese traditionally does not separate words with spaces. So if you ever have Chinese text and you split it, you're not going to get the words out. So in general, the split function does not like return the actual words of things. It just returns what's white space delimited. Sort of conversely, Chinese uses no spaces. Vietnamese uses spaces between every syllable. It uses spaces in the middle of words. And so if we have something like Vietnamese.split, then that'll give us all the syllables in the sentence and not all of the words in the sentence. Just another sort of weird thing about languages. Let's talk a little bit more about emojis here for a second, and this idea of fonts. If you don't have a particular font installed on your computer in VS Code, it'll show up typically as a box like this. But fonts are the subject of enormous controversy in the Unicode world. And this, the story of Apple and the gun emoji will tell us why. This particular web page right here, if you ever want to refer to it again, is found on our README file for this week. There's a bunch of references listed down here. Again, these are the references for if you want to read something about what we talked about in class. All the material from class either comes from these fun links down here or this Python tutorial right here. And what happened is that in 2016, prior to 2016, this is what Apple's font for the gun emoji looked like. But after 2016, because of some shooting that I don't remember, Apple decided to change their emoji to this. And this has a very semantically different meaning than this emoji right here. And this leads to a particular problem if you have sort of like this imaginary conversation. Here's somebody on iOS, they say, 2 p.m. tomorrow, local park, bring it, squirt gun. And this is how it shows up on iOS, like, oh yeah, let's go play. But if you're on any other phone, these are the fonts that get displayed for those other phones. And these are much less innocent sort of text messages to receive. I'd be very confused if somebody that I was not like a deadly enemy with sent me something like this. And so this is very controversial on Apple's part to do this. And not only does it change like the meaning of these text messages between phones, but like it also retroactively goes back in time and changes the meaning of like maybe somebody sent this message right here on an Apple device in 2012 and intending this emoji to be like, I'm actually threatening you. I want to kill you with my physical handgun. But now if a historian goes back and looks at this from their Apple device, looking at a message from 2012, they won't be able to tell that it was this threatening message. They'll see this sort of fun message. So most font choices don't have this sort of semantic impact like this, but some font choices can, especially in the emoji world. And yeah, so many weird things about languages that you may or may not have thought of before. Okay, last time we sort of started with this technical, really technical material. This is the stuff that you really have to know for completing the future labs and projects in this class. And that's information on encoding. So again, the idea of the encoding is the way that a text object, a string or a character is physically stored on the computer. That the computer can only knows about numbers. And so somehow every particular letter that we want to use has to be represented as a number. The traditional way of representing numbers in a computer, and the one that all modern computers use, is that numbers are always broken down into units called bytes, which are 8 bits long, a bit containing a 0 or a 1. And so 1 byte has the information, can store numbers between 0 and 255. This number was, or this size of a byte was chosen for a number of convenient computational reasons, but also because it's just barely big enough to store ASCII values, and so that all English letters take up exactly 1 byte. We saw that in Python, there's these, so we've been using this type of string before where we just have the single or double quotation marks. This R in front of a string, this is still the same string type. It's just like a fancy way of creating strings, just like a single quotation. Oh, I guess I'll write it up here. Just like that, single quotation and double quotation make the same string type. R that, and R that, R double quotation make the same string type. And that's confusing because if you add a B out in front, this doesn't make a string anymore, this makes a byte object. So if I type out normal down here, normal strings like this. We have just quotation marks. It's just a string. If I type out raw strings like this, the R right here standing for raw, we get that it's still the normal quotation mark, still just a string. But if I type out example down here, we get this B down here, B standing for byte. It is not a string anymore. This is called either a bytes object or a byte string. If we have something like that equals R of that, these two things are in fact equal. That's going to give you true. But if you replace that R with a B, these things are no longer equal to each other. The byte version of a string is no longer equal to the actual version of a string. Strings can represent any possible character that people have come up with and are representable in this Unicode system somehow. So it's sort of like the most universal representation possible. Bytes can only represent bytes. This values between 0 and 255. And so in particular, if we did this other example where if we have some like letter that's not an ASCII value, I have Korean example right here. If we have something that's not an ASCII value, I can store that in a string, but I cannot store that in a byte. If you recall, the ORD function like this tells me the number that Unicode associates with any particular character. This character right here happens to have number 52,980. That's bigger than 255, so it can't fit inside of a single byte. And so this this B doesn't work with it. Any questions so far? Yes.
One thing I'm not sure if I missed, but the single versus double quotation marks in the note that you typed.
No difference at all between single and double quotation marks. The reason why Python supports both of them is so that if you want to make a quotation mark containing a quotation mark, it's you just make your string wrapped in the opposite one, and that way you don't have to do something like this, escaping it. This right here is the same thing as this. This backslash quotation mark means that this quotation mark right here is not the end of the string, just the actual string literal character. And so these two things are just different ways of representing the same value. But if we put that B out in front, they are no longer the same thing. That's the key, like one thing that you must have taken away at this point is that if there's a B out in front, it is never going to be equal to something without a B out in front. Good question. Any other questions so far? Okay. Files. Anytime you have a file or in Python or in any language, that file is always stored as a sequence of bytes. And so this is what we're building up to, is how we interact with those files. In order to interact with sequences of bytes, somehow convert these B things into regular strings, we have to use what's called an encoding, which is a system of converting bytes into characters. The .encode function converts a string into a byte. So if I do something like a.encode ASCII like this, that converts the A without the B in front of it into an A with the B in front of it. In ASCII, we can store everything as a single byte. So these two things are going to happen to be the same thing. There are other encodings that I can use. Another popular one is called UTF-16. UTF-16 stores everything as 2 bytes. This 16 right here stands for the number of bits. So 2 bytes is 16 bits. And if I do that, then we can see that it's a much larger string right here. And in fact, we get these 3 bytes as output. I know there's 3 bytes because this \x again represents represents a single byte, a single number, a single hexadecimal number, and FF right here is the first byte. Then this right here is the second byte, and this right here is the third byte. Question?
Is the reason why is because A isn't even close to 16 bytes worth, so it just fills up the empty spaces with FF, and that just A is what matters there.
Question is like, why is why exactly is this the byte string that corresponds to the letter A in UTF-16? And the answer is that it's a super complicated reason, and basically nobody actually understands like the magic behind that goes into associating numbers with each of these different types of encodings. It involves a lot of weird discrete math things and a lot of weird linguistic knowledge, and so everybody just treats it as magic. We just know that something comes out, and that's all. That should just be your takeaway, is that there's some byte string associated with each particular letter, and that's it. So the encoding, again, goes from a string to a byte. The decode converts from a byte back to a string. So if I say B equals this thing right here, so B is that same thing, and I do B dot decode UTF-16 like that, then I'll get my A back as an actual string. So decode removes the B out in front, gets rid of all this gibberish, makes it back into something semantically human readable. Encode converts from the semantically human readable thing to the computer gibberish that starts with the B. If whatever you encode something as, whatever you encode it as, you must be the same thing as you decode it as. So here I did B.decode with UTF-16. If I did B.decode with, say, ASCII, then in this particular case, I'm going to get an error back because it turns out there is no valid ASCII byte sequence that has these particular values inside of it. The most popular of these encodings is called UTF-8, and we'll see some examples of UTF-8 working in the next few sections of this code up here. But one of the reasons why UTF-8 is popular is because it agrees with ASCII that for all English letter characters, they have the same byte representations, and most text on the internet is English. So UTF-8 has sort of somehow become the standard. So I have these 5 different bytes variables down here. I know they're all going to be bytes variables because they start off as strings, and then I call the dot encode on them. And when I call dot encode on them, again, encode converts from a string to the bytes object. And because I'm using different encodings down here, I'm going to get potentially different results in my byte strings. So if I do like bytes 1, it just still looks like hello world. Every one of these bytes that can be represented by an ASCII English value is just to save some space in like the gibberish down here. If we have bytes 2, then this is the UTF-16 encoding, gives me this big long thing. Bytes 3, an even bigger longer thing. Bytes 4, back to this, so this ISO 8859-1 happens to also agree with ASCII. And then if I do bytes 5, also get ASCII back. So sometimes an encoding can give you the same byte string for certain strings, but in general, they're not guaranteed to. For English, it's relatively common for encodings to do the same thing as ASCII. Let's see. So again, I mentioned this before, but I'll state it again since I wrote it here as this principle number 3, that whenever you're working with bytes, you must know somehow what the encoding was that you used to convert from the string to the byte. If you don't know that encoding, then you can't get the original string human readable stuff information back. And so let's look at these Chinese characters now a little bit. If I type, so the text right here inside the human readable string Chinese, and the bytes is all going to look like total gibberish to us. We're not going to be able to see any human readable pattern here. If I do Chinese underscore bytes 1 like this, just a bunch of gibberish looking stuff down here. Chinese bytes 2, more gibberish stuff, and Chinese bytes 3, more gibberish stuff. If I tried to run something like this, taking these Chinese code and encoding it using this particular encoding over here, this particular encoding doesn't have any values for these Chinese characters defined, just like ASCII doesn't have any values for these Chinese characters defined. And so we get this error message saying that ASCII can't work with this code, with these strings. You must pick a different encoding. One of the things that's important, so again, we saw this last time, but if you use the length function will tell you which one of, or will tell you the number of bytes used by a particular encoding. And one of the reasons different encodings have been invented and people use different encodings is because different encodings result in either more or fewer bytes being used for a particular application. For Chinese text, UTF-16 happens to be the most space efficient encoding. That if we use this UTF-8 up here, then we use 36 bytes to store this versus 26 bytes in UTF-16. So in Asian countries in general, actually in the vast majority of countries in the world, UTF-16 is one of the most efficient encodings. And so for a long time, people were pushing to make this sort of the most default standard. If you're on a Windows computer, then this is probably the default encoding on your Windows computer, UTF-16. If we compare these three values right here, Chinese bytes 1, 2, and 3, we're getting these numbers right here. Chinese bytes 2 with UTF-16 has the smallest number of bytes in use. If we compare that to English up here, these three encodings, bytes 1, 2, and 3, length of bytes 1, length of bytes 2, length of bytes 3, bytes 3. We'll see that for English text, UTF-8 is actually the most efficient encoding because it uses the fewest number of bytes. So it can be stored on your computer most efficiently, whereas UTF-16 uses more bytes than UTF-8 for English language text. And so for countries like the United States have been pushing UTF-8 as the default standard. And because the US basically owns the entire internet, today, like 90% of internet traffic is done in UTF-8. The vast majority of programs, if you're not on a Windows machine, use UTF-8 as their default standard. And today, it's like about half of Windows machines use this as the default, and half of Windows machines use this as the default. So one of the principles here, the last principle for us to mention here, is that some encodings are better for some languages than others. And it turns out there's a whole bunch of political issues about like countries wanting certain encodings for different places. Pause there and question.
Why, I understand why you want to encode it for like the computer side, but when you're writing your own code, when would you use the encoder decode function?
The question is, when you're writing your own code, when do you use these encode and decode functions? And that's what we're going to get to next with files. That files are always stored as individual bytes on your hard drive or wherever you're storing your file. It's stored as individual bytes. And so when you load the file from the computer, it's going to come out as one of these byte strings. And in order to get the actual human readable text, you have to call the appropriate encoding or decoding to convert between the human readable text and the bytes themselves. Besides working with files, it's also the case that when you're, say, like scraping things from the internet, the things that you're downloading from the internet inside of Python will always come to you as bytes, and you somehow have to convert those bytes into human readable text. And so you have to use these encode and decode functions in order to do that. Good question. If the motivation of encoding and decoding is not 100% clear, then that's okay at this point. The main thing that that you will want to make sure is 100% clear before next week is that the encoding and decoding convert between the strings and the bytes. Any other questions so far? Okay, then now we're in a position to actually talk about working with files in Python. And so we're going to switch over to this notes_files.py file. And down here, I'm going to press Control D to exit out of the terminal. That's the same as typing exit. And have this file opened up for us. I'm going to start by just running this file. So we'll press the triangle button up here on, so it's again the notes_files.py that I'm running. We'll run that, and we'll see that we're getting this error message down here. And so let's talk again a little bit more about how to interpret these error messages when you come to them. You always start from the bottom and then progress to the top. The very bottom line always tells you exactly the name of the error message in Python. In this case, it's saying the file not found error. And then the next line above tells you exactly what line that's happening on inside of what file. This is the notes_files.py file, and it's happening on line 7 right here. This open function opens whatever this file is and gives us access to the contents of this file right here. We're getting this error message, file not found, because I don't have any file named, in this case, example_file. My variable file name is this string example file, and when I pass that to open, nothing's going to work. So in order to make it actually work, I'm going to right-click up here on the folder that I've opened inside of this open folder. My open folder, when I clicked file up here and then open folder, I went to this topic 5 Python file manipulation folder. And so that is where I'm going to create a new file at. So if we right click down here. File, new file, there we go. And we'll call this test, Control S, save that, and example_file, save that. And here we go, we've created a file named example_file in this sort of what we call the top level folder sometimes. And now that I have this file, if I come down here, up arrow, run it, there's not going to be any error messages. If I rename this file to something else, example_, rerun it, I'm going to get an error message because it's looking for example_file. Come over here again, F2 lets you rename things, give it back to the correct file name, and it's running without any errors now. So yeah, we haven't talked about what this code's actually doing yet. We've just gotten rid of that error message. Any questions about what I just did?
So
Yes.
what exactly are you typing in to get there? Are you just trying to?
So in order to get the error message, if you press the triangle button up here to run the file without actually having created a file named example file, you'll get an error message. So over here, if I don't have an example file like that, and then under my notes files, press the triangle button, I'm getting this error message. Because I'm running this, it's coming to this line 7 right here. Line 7 is opening the file name, and it's getting this file not found error. That tells me I know that this file right here doesn't exist, and so I need to create it somehow. Example_file creates the file. Now over here, under notes_files.py, I press the triangle button, and everything runs without error. So it's the first like common thing that happens with files is getting this file not found error. Any questions? Other questions?
Yeah, I initially put the file inside another folder. Why does that not work? Why does it have to be on my
Yeah, so the question is like, why does the file have to be in exactly this location, and it can't be, for example, in a subfolder or maybe a parent folder? And the reason is because what if your file, like, we could have multiple files named example file in different locations on your computer, and the only way for Python to know which one that it should actually look at is if it's in this exact folder. a little bit later, probably not today in class, but next week, we'll talk about how you can access files that are in different locations, sort of spread out throughout your computer. But for now, just this is the, like, whatever you did file open folder with, that's the location where you need to put this example file.
You don't have to do that.
An example file does not have to have a .py at the end of it. It just needs to match whatever name you're passing into this open function. So in this case, I have example file with no py at the end, and so that's what it should be. In the Windows world, it's common for text files to end in .txt, something like that. But this is sometimes called the file extension over here. These file extensions actually have no meaning. The computer doesn't interpret them at all. And so outside of the Windows world, it's popular to not include these file extensions, especially if the extension is a .txt. Just sort of the default. We should think about files as being text. Yes?
Is your notes on these files also within the topic file?
Question is, where's my notes files.py located? And the answer is, in this case, I happen to have it in the same folder as example file. That it's they're both located in the place where I did the file open folder at. It'll actually, everything will still work no matter where your notes files.py is located at. If you are running into various errors still with this file not found error, then happy to work with you after class. I can probably fix it for you in just 20 seconds. But that'll be a one-on-one. We'll have to sit down and look at your computer together. The main thing for us to look at next is what this open function is actually doing. This open function is always used with this pattern. Sometimes we call this the with clause, where we say with open file name and then as f, or as something over here. And whatever we put over here is a variable that we then have access to. The most common way to access this variable is with the f.read function. F.read reads the entire contents of the file and puts it into this variable over here called text. I'm going to just comment out the rest of this file for a second so that we can focus in on just what these lines up above 9 are doing. So I've just added these quotation marks here to comment out everything in the file except, or everything after line 9. And now when I press the triangle button here and run it, we can see that we get one line as output down here. It says text equals, and then it has this B in front of it. So we know it's somehow a byte string that is being outputted. And it has the word test inside of it. Where this word test comes from is the inside of example file over here. I have this word test. This word test is an English language word, so it fits inside the ASCII range. But I'm going to go now to my notes_Unicode file, and I'm just going to find some random Chinese text, copy that, Control-C, and put it in my example file down here, Control-V like that, and save that. And so now this is not English language text. It does not fit in ASCII. And so let's see what happens when we read the contents of that file and print it out. Press the up arrow again to go back to my command running the notes_files.py, and I hit enter. And now we can see that here it has this test. I understand what the \n means because that's the new line. And in my example file, I have 2 new lines here before getting to the Chinese text. And then there's this whole bunch of gibberish machine stuff that is not human interpretable, but this corresponds to all the Chinese characters. So again, whenever you're storing files on a computer, or somehow anytime somehow Python is interacting with information outside of Python, it's always interacting with it at the byte level. And so you'll always get a bytes object back. In order to get actual text out of this, I have to, again, decode that text. And so text.decode, and I have to know what is the encoding that text was used, or what is the encoding that text used. The vast majority of your computers, VS Code is going to default to UTF-8 like this, and so this is what you'll want to do. Text.decode UTF-8, save that down here, up arrow rerun, and oops, I made the classic mistake of, again, string functions do not modify the string at all. So in order to modify the string, you have to do text equals text.decode. This will convert the text from a string, from a byte string into a regular string. And now down here, up arrow, rerun it, and we get the actual Chinese down here. The same exact thing as I saved over here. If this is not working for you for whatever reason on your computer, your VS Code may have saved the file as UTF-16, especially if you're on a Windows machine and your default language is not English and you purchased the computer like more than a couple of years ago, then this will be the default. Any questions about what I had to do right here on this line in order to go from this byte string containing a whole bunch of random gibberish down to the actual correct text containing the both English and foreign language text? Okay, so this is such a common pattern of reading from a file and then decoding it that Python can do all of that for you in just a single line. And in order to do that, we modify how we call this open function. Over here, I didn't talk about exactly what this string was doing, but the B right here, the B stands for, technically it stands for binary, but I just think bytes in Python because that's what the output is going to be, is bytes. And the R stands for read. So this is, I'm reading the file and getting bytes out of it. If I remove the B and just have R, then it's going to automatically do the conversion into a string for me. Remove the B, then Python will automatically convert from bytes to string. So up here, we had to manually do this conversion. This is such a common process, though, that it's common to open things up. Sometimes this is called opening it in text mode, called opening the file in text mode. And whenever you open the file in text mode, you have to specify the encoding, and because you have to know the encoding in order to decode. And so UTF-8 is probably what you want for your machine. And now you only need one line down here of text equals text.read. And if I come down here, let's first save this, save, down here, up arrow, rerun that. And error message because I have the quotation marks that I deleted and forgot to add back. There we go, save that down here, up arrow, rerun it. And you can see that this is the first printing of this text corresponding to line 12 up here. And then this is the second printing of the text down here corresponding to line 18. Again, because decoding is something that you basically always have to do, Python has it built in for you. You can just specify R right here to read from the file, specify the encoding, and then just do f.read, and it'll give you a string back instead of a byte string. Any questions about that? Okay. Let's see. We have about 5 minutes left. The last thing that I have down here is what's called absolute versus relative paths. And this is something that'll, I think, take us a little bit more than 5 minutes to cover. So we'll go ahead and end early today. If anybody has questions about getting your VS Code, like working with these files, then feel free to, we can use these last few minutes to talk about that. But otherwise, I will hope you all have a good rest of your day, and we'll have the lab like normal on Friday.
Having a file takes not that.